Day 17, page 234, problem 18. This one's a little bit of a challenge. We did one like this. Actually, we did this problem last year. You're looking for a spot in space, which I've labeled with that black dot, where the force that the Earth exerts on a ship of any given mass, really won't matter, is equal to the opposite force by the Moon. I'm not drawing the forces that are being exerted by the spacecraft on the Earth or the Moon because we're only looking at the spacecraft here. And what we want is that we want F sub E, the force that the Earth exerts, let's call F sub E, equal the force that the Moon exerts. And it's Newton's law of universal gravitation in both cases. In other words, that's G, mass of Earth, times the mass of the object over, we'll call this R, well, it's not the radius of the Earth, but it's the radius 1. It's the distance from the center of the Earth to where we're at. Call that R1. And we'll call this R2, R sub 2. So that's equal to G mass of Moon, mass 3, divided by R2 squared. Forgot the square over here on the left-hand side. Alright, so as we can see here, like last year, the G's will cancel out, the small mass will cancel out, doesn't really matter. And the real neat little trick here is just to take the square root of both sides. And when we do that, we end up with the square root of the mass of the Earth over R sub 1 equals the square root of the mass of the Moon over R sub 2. Now what you want to look up is in the cover of your book, or just Google it, they're known numbers, the mass of the Earth and the mass of the Moon. You would know those numbers, you plug them in. You also can look up the total distance between the Earth and the Moon. Those are all numbers you would look up and they would be known. So let me label them in the diagram. So I would know this total distance between the center of Earth and center of Moon. I'll call it R sub 3. Unknown number. The bottom line is R sub 1 plus R sub 2 will equal R sub 3. And then R sub 3 is known. But if you look at that blue equation I wrote over there, then I could solve for R sub 1 or R sub 2. In other words, R sub 1 will be equal to R sub 3 minus R sub 2. And I know R sub 3. What you'll want to do is take this quantity here, which is an expression, R sub 3, a known number, minus R sub 2, and plug it in for R sub 1 over there, and then just do the algebra from there on out, because the only unknown will be R sub 2. You'll take the square root of those big numbers, cross multiply, and solve for R sub 2. Once you have R sub 2, you can figure out R sub 1. That's the location where there'll be apparent weightlessness, really, because the two forces will cancel out, and the ship will just be suspended there in that particular location.